All right, so today we're going to be talking about circuits. There's two types of electrical currents. The first type would be alternating current, which we represent as AC, and that means that the electrons will alternate the direction they flow depending on if it is on or off. And then there is direct current, also known as DC, and that means that there is only one way for the electrons to flow. So what is an electric current? That means that there's a pathway for electrons to flow, and in order for that to occur, there's a couple of essential things you need. You need a power source, you need a load or lamp or light bulb, that's whatever's using the power source. You'll need wires to connect all of this, and then a switch to turn it on and off. There's two types of circuits we're going to talk about. The first one is series, and the second one is parallel. So series circuit, that means that everything is connected together and there's only one path for the electrons to flow. So as we can see on here, the electrons can flow one way and one way only. And that means if there is a break, let's say in this wire or this wire over here, then the whole circuit would stop working. That is also true is if this light bulb were to go out or if this light bulb were to go out, the whole circuit would stop working. And then we have our parallel circuits. This is different because there's multiple pathways for the electrons to flow, meaning if there is a break in this wire, then the electrons could still flow in this wire down here. If this light bulb were to break, then the electrons could still flow through the top wire. So the electrons have multiple paths for the electrons to go. And we're going to be looking at circuit diagrams, and when we look at circuit diagrams, this would represent a battery. So whatever is powering the electrons. We have a lamp or a light bulb. We have a switch, and this one right now is open, meaning the electrons would not flow through it. The switch always needs to be closed in order for the electrons to flow. And then everything connected is the wires. So we're going to be using Ohm's law when we look at circuits to calculate the three variables. The first one we're going to look at is amps. So in a series circuit, amps will be the same throughout. So there's 2 amps here, so that means that there's going to be 2 amps here and 2 amps as well there. So again, current or amps is the same throughout in a series circuit. In a parallel, it is going to be shared. So if this wire has 2 amps, that means that the 2 wires down here would share those amps. So each would get 1, and then when it comes back together over here, it would be 2 amps. So in a parallel circuit, current is shared. So discussing this, we see this is a series circuit, and this wire down here has 4 amps. So we know that in a series circuit, the current stays the same. So this would be 4 and this would be 4 as well. This one right here is a parallel, meaning there's multiple paths for the electrons to flow. We see there's a total of 3 amps. So each would get 1 amp on each branch, and then it would come back together to be 3. Now we can look at voltage. So in a series circuit, voltage is going to be shared. So if this battery had a power of 3 volts, it is going to share its voltage between each light bulb. So this light bulb would get 1.5 and the other one would get 1.5 as well. So in a series circuit, voltage is shared. In a parallel circuit, it is going to stay the same. So if we have this battery and it's 3 volts, that means that this light bulb would get 3 volts, and this light bulb would also get 3 volts. So parallel circuit, voltage stays the same. Here is a little diagram chart to help you remember those. So series circuit, current stays the same. In a series circuit, voltage is shared. In a parallel circuit, current is shared. In a parallel circuit, voltage stays the same. So we can kind of test our knowledge now. This is considered a series circuit since there's only one path for the electrons to flow. We see that the current is 4 amps, and we know that current stays the same. So this would be 4, and this would be 4 as well. Then we can look at voltage. We know that voltage is shared. So we have a total of 6 volts. So this would be shared with 3 and 3. Here we have a parallel because there's 2 paths for the electrons to go. We see the current over here is 4 amps, and we know current is shared in a parallel. So this would get 2, and this would get 2 as well. And this would be 4 when they come back together. We see this 6 volts would be the total voltage in this battery. That means that this would get 6 and this would get 6 as well, because in a parallel circuit, voltage stays the same. And then we can measure resistance. So in a series circuit, voltage is just going to be added to, or the resistance is just going to be added together. So 3 plus 2 will give you 5 ohms of resistance. So in a series circuit, you just add them together. And after every bulb, there's going to be a voltage drop, and we're going to be using Ohm's law to calculate this. So we found the total resistance to be 5, and now we're going to use it to calculate current. So we know that current is voltage divided by resistance. And our total voltage we have is 6. And our total resistance we just found was 5. So we're going to divide that. So our current is 1.2. So again, we know that in a series circuit, current is going to stay the same. So current is 1.2 on this branch. Current is 1.2 on this branch, and 1.2 on this branch as well. So then we're going to calculate how much voltage drops across each resistor. So essentially we're going to use voltage equals the current, which is 1.2, times this resistor, which is 2. So 2.4 would be the voltage drop. And then over here, that voltage drop would be, again, voltage is the current, which is 1.2, times that resistance, which is 3. So you're going to multiply those together, and you'll get 3.6. So again, in order to find voltage drop, you're going to solve for voltage, which is current times resistance, and you're going to use the current, which is the same throughout, and the resistance on each bulb. So you'll have the voltage drop for each bulb. And then we can look at the total resistance in a parallel circuit. So instead of just adding them up like a series circuit, we're going to be using this formula here. So our R1 would be our first resistor, and R2 would be the second resistor. So to plug it into this formula, it would be 3 times 2 divided by 3 plus 2. So 3 times 2 would give you 6, 3 plus 2 will give you 5, 6 divided by 5 is that 1.2. So again, for a parallel circuit, in order to find total resistance, just use this formula here. That R1 would be the first resistor, R2 is the second resistor. And now you're going to complete the practice worksheet.